Assalamualaikum warahmatullahi wabarakatuh and good day class. So let's us continue our lesson. So as you know, we have three subtopic. So we done for 3.1 galvanic cell, and today we go to Nernst equation. Alright. So after the end of this subtopic, you should be able to write Nernst equation for a given galvanic cell, explain the factors that affect cell potential, use Nernst equation to determine cell potential, concentration or partial pressure of species, and equilibrium constant K when E cell is equal to 0, and predict the spontaneity of a cell reaction. So the E cell of a voltaic cell is affected by the change in temperature and concentration of the solution involved non-standard condition. The E cell for a reaction under non-standard condition can be determined by using the Nernst equation. So E naught for non-standard condition, we use the Nernst equation. Nernst equation is given by E cell is equal to E naught cell minus 0.0592 over N log Q. Consider a voltaic cell where the overall cell reaction is A plus B produce C plus D. The Nernst equation for the overall reaction is E cell equal to E naught cell minus RT over NF ln Q, where the R is 8.31 joule per Kelvin per mole, T is the temperature in Kelvin, F is Faraday constant, 500 coulomb, and then N is the number of moles of electron transferred. Q is reaction quotient, concentration C power of C times concentration D power of D, okay, the small d, and C here is for coefficient, and over concentration A power of A, B power of B. So this is only the derivation for Nernst equation, no need to know about this. And you have to memorize this one. E cell equal to E naught cell minus 0.0592 over N log Q. At equilibrium, no net reaction occur. That means Q is equal to K. So E cell is equal to 0. When E cell is equal to 0, E cell here is equal to 0, that means E naught cell, we rearrange the formula here, so that means E naught cell equal to 0.0592 over N log K. Example, determine the E cell for the following cell. Okay, so given here is the cell notation for our cell. So here given the value of SRP from the SRP table. Alright, so first of all, you have to find the E cell, right? So first of all, you have to find the E naught cell using the formula we learned before, which is E naught cell equal to E naught cathode minus E naught anode. So E naught cathode, so from the cell notation given, cathode is copper. Alright, so E naught cathode is equal to E naught copper is positive 0.34 minus negative 0.76. This is E naught anode. Anode is zinc. No need to change the sign here, okay, because we use this formula. So the value here is positive 1.10 volts. Write the balanced redox equation, okay, to get the Q. So this is the balanced redox equation or overall equation. So N is equal to 2, okay, because of the number of electron, okay, number of mole of the electron. Okay, so calculate the E cell using the Nernst equation. Okay, write the formula and put the values. Okay, so the concentration of the zinc 2 plus and Cu2 plus here. Okay, so we get here 0.02 molar. Okay, masukkan nilai zinc, masukkan nilai copper, Cu2 plus ion, and then get the final answer, positive 1.14 volts. Okay, so remember that the Nernst equation here we use because of the non-standard condition of the cell. Okay, example 2. Calculate the E cell for the following cell. So given here the cell notation, okay, noted here, okay, 0.03 molar, 0.002 molar. That means the cell here is not non-standard condition. So with the non-standard condition, we use Nernst equation. Okay, so from the standard reduction potential values, okay, Cu2 plus, okay, Cu here, Cu dan Cu2 plus, okay, that's mean kita guna yang ni, Cu2 plus become Cu, so positive 0.34. Okay, don't worry, dalam exam dia akan bagi directly, okay, dia tak bagi equation ni, dia akan bagi nilai terus. And then for silver is positive 0.8, okay, volts. So for silver, okay, silver here is cathode. Okay, we use a cell notation adalah A, B, C, right kan? So C kat sini adalah cathode silver, anode adalah copper. Okay, anode adalah copper. And then first of all, you have to find the E naught cell using this formula. Okay, no need to change the sign here. Step 2, write the balanced redox equation because you want to know the Q. Alright, so just put the Q here is the concentration only, okay, for aqueous, okay, yang solid abaikan. And then determine the N, okay, N bila kita balance equation, the number of mole of electron is 2. So calculate using the Nernst equation. Substitute all the values, okay, yang dia bagi value ni masukkan dalam concentration Cu2 plus and Ag plus, okay. From the balance equation, okay, look at here, the Ag plus is 2, the number of mole here is 2, okay, the coefficient here is 2, so kena kuasa 2. Okay, substitute all the values and then we get the final answer, positive 0.345 volts. Alright. Next, example 3. The E cell for the following electrochemical cells given positive 0.34 volts. Alright. So look at here. The concentration of zinc 2 plus is not equal to 1 molar. That means this is non-standard condition. So you have to find the X here, okay, using the Nernst equation. Okay, so given there the value of SRP for zinc and nickel is, okay, negative 0.25 for nickel and negative 0.76 volts for zinc. Okay, so using the Nernst equation, first of all you have to find the E naught cell first. Okay, sebab dalam formula Nernst equation ada E naught cell, so you have to find this one first. Okay, so given there the zinc, okay, so substitute all the values and you get the answer. Okay, so put here positive, right? And then E cells given positive 0.34, E naught cell masukkan nilai, and then N is equal to 2, substitute the value of zinc 0.1 molar, and nickel you have to find the concentration for nickel. Okay, so masukkan dalam calculator dan dapatkan jawapan dia. Okay, example 3. Determine the equilibrium constant K for the following reaction. So find the E0 cell first. From the SRP value, the copper is equal to positive 0.34, silver 0.80. Okay, from the overall equation, Cu that is U2 plus, so oxidation number from 0 to plus 2, so dia adalah oxidation process at anode. Okay, and then Ag plus become Ag, okay, we can Ag, and then here is positive to 0, so it is reduction at cathode. Okay, so ingat cathode is silver. Okay, this one is cathode, and then copper is anode. Okay, find the E0 cell, positive 0.46 volts, and then at equilibrium, okay, at equilibrium, E cell is equal to 0. That's mean the formula, we rearrange the formula, the Nernst equation, okay, we rearrange the Nernst equation, become like this. Right, so put all the values here, n is equal to 2, log k, and then we get the k here. Alright, so your homework for that LO is page 29. Then let us continue. Spontaneous and non-spontaneous cell reactions. A cell reaction is spontaneous when E cell is positive and non-spontaneous when E cell is negative. Alright, so for this one, ingat lagi tak sebelum ni kita belajar spontaneous and non-spontaneous itu adalah untuk standard condition, iaitu E0 cell. Okay, bila dia positive, okay, it's spontaneous. When it is negative, it is non-spontaneous. Okay, but then for non-standard condition, okay, for non-standard condition, we refer E cell, not E0 cell anymore. Alright, so this one is for non-standard condition. But it's non-standard, yang selain daripada 1 molar, selain 25 degree C, selain daripada 1 atm, itu adalah non-standard condition. Example, with reference to galvanic cell below, okay, so cell notation is given. Okay, look at here, the condition here, the concentration of Ni2 plus is 0.02 molar. Maksudnya bukan 1 molar. So this is not this non-standard condition. Alright, non-standard condition. So write the overall cell reaction equation. Predict the spontaneity of this galvanic cell. Okay, write the overall cell reaction first. Okay, kita buat dulu overall. Kalau tak boleh buat overall terus, buat anode and cathode first, baru buat overall. Okay, ini Madam terus tulis jawapan for overall cell reaction. Okay, so nickel akan become nickel 2 plus, and then kita ada Cl2 become Cl minus. Okay, so kalau kita congak saja, kita dah tahu dah dia punya N adalah sama dengan 2. And then predict the spontaneity of this galvanic cell. So bila diminta spontaneity, kita kena ingat dia adalah non-standard condition. Bila non-standard condition, spontaneity dia kita akan refer pada E cell, sama ada positif ataupun negatif. Alright. So soalan ni dia tak bagi SRP. Okay, tapi kita buat latihan soalan tutorial, kita boleh refer dalam buku mastery kat bahagian hadapan. Okay, dia punya nilai. Okay, so for chlorine it is positive 1.36 volt. Okay, and then for nickel negative 0.25 volts. Okay, so when we want to predict the spontaneity of this galvanic cell, okay, so from the value kita dapat daripada SRP, okay, and then from the cell notation kita dapati Cl2 adalah cathode, okay, nickel adalah anode, cathode, okay. So find the E0 cell first using E0 cathode minus E0 anode. Masukkan nilai dan dapat jawapan akhir positif 1.61 volt. Tapi ini bukan lagi jawapan dia. Kita tak boleh cakap, okay, this is a spontaneous reaction. No, okay, because this is non-standard condition. So, kita proceed to the Nernst equation. Okay, masukkan nilai. So, for the product, we have aqueous. Okay, dua-dua aqueous. So, masukkan, darabkan. For Cl minus, okay, dia mesti dia ada 2 di hadapan, so kena letak power of 2. And then here we have gas. Okay, gas kita ada chlorine gas, so letak pressure Cl2. Okay, untuk solid tak perlu. Then substitute the value here, E0. Okay, N is equal to 2. Okay, 2 ni dapat daripada mana? Okay, bila kita buat N0, cathode punya half equation, kan kita ada tambah 2 elektron, ada 2 elektron agak-agak. Inilah elektron yang ni. Okay, so that's why bila tak boleh congak, kamu boleh buat dulu dia punya half equation for anode and cathode first, and then kamu identify with, what is the N here from the electron. Okay, baru dapat 2 kat situ. Okay, and then masukkan nilai. Dan kita dapat positive 1.72 volt. That means E cell is positive. Okay, because that means E cell is positive, so the reaction is spontaneous. Okay, now, so kita tengok what is the factors that affect the cell potential. E cell, okay, E cell yang ni from the Nernst equation. So value of E cell is affected by, first, concentration of reactant and product. Increase the reactant or decrease the product will increase the E cell. Okay, so that's mean macam ni. Apa kaitan E cell? Kita tak nampak concentration dekat sini kan? Okay, we know that okay, here we have Q here melibatkan product, okay, and reactant. Okay, so bila kita increase the reactant, okay, reactant di bahagian bawah kan? Okay, and then so this is a reactant, and then atas ni adalah product. Bila kita increase the reactant and decrease the product, okay, dia akan increase the E cell. And then the second one is temperature. Okay, lowering or increasing the temperature will change the value of E cell. Okay, yang ini dia tak pergi lebih tepat. Okay, nanti Meda akan elaborate kemudian. Okay, so ini KIV dulu. Okay, sebab dia ada kes-kes yang tertentu lah. Okay, and then yang ketiga adalah type of half cell. Using half cell with more negative SRP values as anode will increase the E cell. Okay, and then using half cell with more positive SRP value as cathode with increase the E cell. Okay, dia macam ni cerita dia. Kalau sebab kita tahu E cell, E0 cell, okay, dia akan increase kalau kita guna yang more positive value pada cathode. Okay, dan juga dia akan increase juga kalau kita guna half cell di mana anode dia tu yang more negative. More negative. So dia akan increasekan E0 cell. Bila E0 cell increase, automatically E cell pun akan increase. Alright, kita tengok example. Table below shows the standard electrode potentials for various metal. Okay, so dia bagi E0 dekat sini. This is SRP. Okay, this is SRP. Arrange the metal given above in order of increasing strength as reducing agent. Okay, ingat balik tak kita dah belajar hari tu reducing agent. Okay, reducing agent, siapa reducing agent dekat sini? Okay, cuba kita buat satu contoh. Contohnya B+. Kita buat equation B+ ni kalau dia terima elektron, dia akan menghasilkan B. Okay, this is what? This is reduction process, right? Sebab dia terima elektron. Okay, bila terima elektron, maksudnya dia reduction process. Bila reduction process, pada reactant ni adalah oxidizing agent. Okay, that means ini adalah reducing agent. Okay, bermakna siapa reducing agent? Okay, yang ni E, F, D. Okay, yang tu kita target yang tu. Jangan tulis yang ada charge tu. Okay, dia nak increasing strength as reducing agent. Reducing agent dia buat proses oxidation. Okay, oxidation, siapa yang lagi senang oxidize? Yang lower E0. Okay, yang lower E0 dia lagi senang nak oxidize, senang nak buang elektron. That means reducing agent dia akan, okay, reducing agent dia akan jadi stronger. Okay, so siapa yang paling rendah? Okay, siapa yang paling rendah adalah E. Okay, so bermakna E adalah paling tinggi lah. E adalah paling kuat. Okay, followed by what? Negative. So settle yang ini. Negative 0.28. Okay, C. And then 0.34. So D. And then after that, B. And then the weakest reducing agent is F. Okay. Okay, alright, sama. Okay, tengok. With reference to the cell notation given below, write the redox equation for the cell reaction. Okay, daripada cell notation ni, kita tahu ni adalah A, anode, ni adalah cathode. So, anode adalah C, jadi C2+. Okay, and then cathode adalah D+, jadi D. Okay, buat dulu macam ni. Lepas tu, baru tulis dia punya elektron. Okay, pun boleh. So, this is redox equation. So, elektron sama, tak payah darab apa-apalah. Okay. Calculate the E cell at 25 degrees C if the concentration of C2 plus and D2 plus ion are 0.01 and 0.1 molar respectively. That's mean this is non-standard condition. So, we use Nernst equation. Okay. So, Q here is referred to the overall equation. Okay. First, find the anode cell using the formula cathode minus anode. So from the table given before, okay, so substitute the value and we get positive 0.62 volts. Okay, substitute the value of 0.62 volts, and then n is equal to 2 log, okay, the concentration given. And then we will get positive 0.65 volts. Okay, so if the question asks the spontaneity, okay, for this cell, it is spontaneous reaction because of the sign is positive. Alright, so look at page 33 in your notes. The potential for the following electrochemical cell at 25 degrees C is 0.34. So this is the potential for the electrochemical cell, E cell. Okay. So explain how the concentration of the solution at the anode and cathode would change after the cell had been discharged continuously. B. Calculate the standard electrode potential of copper. And then when sulfuric acid is used in the above cell at 25 degrees C and pressure of hydrogen is 1 atm, the cell potential is 0.53. Calculate the pH of sulfuric acid used. Okay, so sulfuric acid maksudnya acid di sini lah. Okay, dia kacau kat sini. Okay, concentration sini. So, from the cell notation given, kita tahu siapa anode, siapa cathode. And then, ini dia tanya what happen kan kalau kita discharge continuously. Kita buat equation dan kita nampak pada produk dia menghasilkan H+. So hydrogen is oxidized to H+ ion. Concentration of H+ ions increase. Maksudnya kita tahu dia increase sebab dia di bahagian produk. So dia akan increase. At cathode, Cu2+ accept 2 electron to produce copper solid. So copper ion is reduced to Cu+ solid, so the concentration of Cu2+ ion decrease. Okay, so ion ni decrease. So dia soalan dia tanya what happen kan the concentration. So maksudnya dia akan decrease sebab dia di bahagian reactant. So lama kelamaan yang ni akan deposited lah sebab dia menghasilkan copper solid. Okay. And then calculate the standard electrode potential of copper. Okay, because of the concentration there and the pressure given pada standard condition, so we use anode cell. Okay, find the dia minta apa standard electrode potential of copper. Okay, so dia minta copper. Standard electrode potential for copper ni adalah E naught Cu2 plus Cu. Okay, so we know that the cell potential adalah 0.34, iaitu E naught cell. Kenapa kita tahu E naught cell yang dibagi? Sebab dibagi semua dalam keadaan standard. Okay, 1 molar, 1 atm. So kita tahu dia adalah for E naught cell, bukan E cell. So kita nak cari E naught copper. Okay, So for anode, okay, dia guna hydrogen, so that means dia punya value is 0.00 volts. So E naught copper is equal to positive 0.34. Ni kita guna She ni, okay. Alright, so the next question adalah, okay, dia minta what is the concentration, dia minta pH, right? So dia kata bila dia masukkan acid tadi, dia punya cell potential jadi 0.53. 0.53 tu adalah E cell sebenarnya. Okay, so dia dah kacau dia punya concentration of the H+, sebab acid kan H+. So soalan dia diminta what is the pH. Okay, bila dia minta pH, first of all you know that, okay, pH is equal to negative log H+. Still remember? Okay, semester 1. So maksudnya you have to find the concentration of H+ using the Nernst equation. Okay, so the concentration or the pressure of hydrogen gas and concentration of Cu2+ doesn't change. Okay, sebab dia tak mention apa-apa pun, tak berubah apa-apa, dia just masukkan sulfuric acid sahaja kan. Okay, so the concentration of sulfuric acid change. Okay, itu yang kamu kena cari berapa dia supaya you can find the pH. Okay. So don't forget to put the 2 here, because from the overall equation H+ dia punya coefficient adalah 2. And then you find that the concentration of H+, okay, is equal to 6.17. Okay, this means here is the final answer. Okay, so ini bukan power of 2, ini adalah betul dia punya concentration H+. And then the pH is equal to negative log H+, masukkan nilai dan awak akan dapat pH is equal to 3.21. Alright. So kita habis Nernst equation. So make sure kalau tak faham ke apa ke, boleh buat lagi latihan, banyak lagi latihan pada buku tutorial, buku mastery practices. And then kalau tak faham boleh tanya madam. So your homework is to do number 11 mastery practices, okay, and then submit kat GC. Yang lain-lain pun kena buat, tapi submit just number 11 sahaja. Okay, so we are done 3.2. Thank you.